All right, I want us to take a look at this quadratic and do several things with it. I want us to graph it. I want us to discern which way it opens, upward or downward. I want us to find the vertex, the Y-intercept, to find the axis of symmetry, all the good stuff, and then maybe even drawing the graph of it. So the first thing let's do is this. Let's determine which way it's opening. And so notice that the A term is -2. So if the coefficient that's on the x squared term, if that's positive, then it's opening upward. If it's negative, like in this case, it's opening downward. So this is A, B is -4, and C is 1. So notice that quadratics are always equations that are written in this form. So in the form of ax squared plus bx plus c. So that's a quadratic, and it's a quadratic as long as a doesn't equal 0. Notice that if the a term was 0, then it would cause this x squared term to disappear, and then it would be a linear equation. So a quadratic is anything in this form. All right, so we've determined that this is opening downward. So it opens downward, so we'll determine that. And then to find the x-intercept, or excuse me, the vertex. So to find the vertex, what we're going to do is use this x equals -b over 2a. That's how to find the x value on the vertex. So notice that -b in this case, the opposite of b, that's what this means. -b means the opposite of b, so that's +4. Since b is -4, the opposite of b is +4. And then 2 times a, 2 times -2 is -4, so this is going to equal -1. So the vertex has an x value of -1. Now to find the y value, what we're going to do is come up here and put that -1 into the equation. So that's going to be -2 so -2 times -1 squared minus 4 times -1 plus 1 there, because I'm putting that x value of -1 in there. Now the way I'm going to do this is I'm doing -1 squared, which is +1, and +1 times -2 is -2. -4 times -1 is +4, and -2 plus 4 is 2, 2 plus 1 is 3. So I get 3 for that value. So the vertex, which I'm going to label capital V, the vertex is -1 and 3. So that's the vertex. The y-intercept can be found by putting 0 in x's place. So if I put 0 in x's place, I find the y-intercept. Now if you put 0 here and there, that's all going to be 0, just going to get 1. So 0, 1 is the y-intercept. And so then what I'm going to do is draw an x and a y-axis. So here's the y-axis. Here's the x-axis. I'm going to label those. I'm going to plot the y-intercept. So the y-intercept's at 0, 1. The or not x-intercept, but the vertex is -1, 3. So -1, 1, 2, 3, like that. And notice this is opening downward. I can also go ahead and do the axis of symmetry. The axis of symmetry is always x equals something. And that something is going to be the x value on this vertex here. So that's x equals -1. So that means I'm going to come over here at -1 and draw a dotted line. And that means that my graph is going to be symmetrical about that. So the axis of symmetry is a vertical line that if you were to cut the parabola about that line and fold it, the two halves would match up. So notice what I can do here. This is the vertex, and since this is symmetrical, I have a point here. I know I'm going to have a point here also. So I already know that this looks like this at this point. Now I'm going to do a couple other values for a table here, a couple other values. I'm going to find out what happens at +1 over here. So if I put this 1 up here, 1 squared is 1. 1 times -2 is -2. -4 times 1 is -4, and then I have +1. So I'm just plugging in that x value here and there and doing the math. So let me double check that. 1 squared is 1, -2, yep. -4 times 1 is -4, and then the +1. So that's -6 plus 1, which is -5. So I know at 1, I have 1, 2, 3, 4, 5. And since I know this is symmetrical here, from here, if you count 2 over, you get to here. From here, I can count 2 over and get there. So I know that this looks like this. Now, I can sketch this out like that. Now, I could do some other points, but this is sufficient. I have the vertex, I have a y-intercept and a symmetrical point. I have this point and a symmetrical point. I could do some other points in the table if my teacher wanted me to, but this is adequate for this graph. So I have the vertex here, and I've listed that up here. I have the y-intercept here, and I've listed that over here, so y-intercept. These are my two x-intercepts, and my parabola is going downward. Now, my domain is all the real numbers, because on a quadratic, the domain is going to be the x values that are a part of this graph, and that's always going to be all the real numbers. Every x value is a part of this graph. But the range is the y values, and the y values start here, and notice it goes downward. So this is 1, 2, 3, so I'm going to say y values less than or equal to 3. That's the range. So the range is the y values that are a part of this, and the y values start here at 3 at the highest point and go down. The other thing sometimes they ask for this is they ask for a min or a max, and notice that because this parabola is going downward, this vertex is a maximum point. It's the highest point, and that's always going to be the y value on the vertex. So the max is 3. So I say the max is 3, and if somebody were to ask me where does it occur, I would say, well, it occurs at -1. So the max is 3, and it occurs at -1. Anyway, this is an explanation of everything you'd want to know and a little bit more about quadratics. So I had a quadratic equation, and I found the vertex using -b/2a. So I found the vertex, the y-intercept, the maximum. I used a table. I found the axis of symmetry. I graphed it. I labeled everything. I found the domain and the range. Hey, you guys have a good one.